Hi and welcome to the lesson about time in streaming processing. So, generally, you will certainly notice the presence of two concepts, the event time and processing time, that are present in the title. And the introduction for this lesson is that when the things happen is not when the things get processed, unless it's edge computing, so unless you are processing data directly, for example, in your IoT device. Why? Simply because you will have to take this data from the source, so the physical source like browser or maybe an IoT device, and move it to your system. And this will obviously take time because it's a network transfer. And to understand that idea better, let's analyze the flow of our imaginary application, and let's introduce different times for this streaming part. So on the leftmost side, you will find the event time because it describes when the user, for example, visited a web page. And later on the rightmost side, so in our side, you will find the processing time because it will be generally indicating when the event get processed. And that's the key difference, because you can see already that we will have different processing times because the data will always take some seconds, hopefully, to be moved from one processing box to another, but there will be always one event time, or at least one original event time that is produced in the source. And there will be different use cases per that. So for the event time, it's a time of the event, like for example clicks on ad or purchase time. And obviously, if you are interested, for example, by knowing when your users are the most active or are clicking the most of your ads, well, obviously you will use event time because it indicates the real action that you are interested in. And for the processing time, is the time of processing of the event. So for example, if you have an early batch job that need just take the data written in the last hour, well, you take data written in the processing time, and there is no brainer for that. And regarding latency, so here there are different latencies, but you can already see one tricky point is that the max latency for both event and processing time is days. So why days for event time? So the problem is that you make one action and it's recorded immediately on the device, on your physical source. But the problem is that this delivery here can take time, and this time it in the best case will be several hundred of milliseconds, but in the worst case, like for example your device that is going offline, and for example you can imagine a scenario when you are navigating a web page, you are making some actions, and the web page script uses some buffering to deliver data at once, and no luck, you lost the internet connection, you close your browser, and you go back 3 or 4 days later. So in that case, when you open your browser, the data will be delivered with this 3 or 4 days latency. And of course, it will be visible everywhere in that part. And here the latency difference between streaming and pipelines is mostly related to different processing semantic, because for streaming we want to process data as soon as it arrives on milliseconds, or in microbatch processing, for example, in 2 or 3 minutes. But on the batch side, you will want probably to take much more data at once and maybe work on dozens of minutes, or maybe by daily basis. And from that you see already another point is that physically the data is already late when you are processing it. And your role in the streaming pipelines will be define delayed data tolerance. So what is the accepted difference between the event and the processing time? That will make the input event integrated in your processing logic. because otherwise you will consider it as too late. So for example, if we take the example for offline weekend of 3 days, you can say that you tolerate only 6 hours of latency, and if you get the events that are older than these 6 hours, well, you simply discard them, and these 6 hours will be your late data tolerance. And there are different strategies. So the first one is the late dropping strategy that I already introduced. So here we are tolerating data. We change the data tolerance time to 1032, and if we get an event older than that part, well, we simply discard it from processing. And the late data tolerance is a high-level name, so it is something that I wanted to share with you in order to make it understandable without introducing the watermark concept that I will develop in the next module that will be much more, I would say, deep dive into streaming and complex streaming processing. And there is also another strategy where instead of dropping the data, because data is an valuable asset and you never know how many items you will drop with the strategy, is to use a dead letter pattern where we have generally the on-time storage and late data storage, and whenever one record is considered as late, we simply write it to this late data storage. We don't lose it, but we will probably need to add some replaying pipeline that will take this late data and eventually integrate it to the on-time data store if needed. And that's all, and I would like to invite you to the next lesson so that you will not be very late regarding your personal schedule. Thanks for watching and see you in the next lesson.